Hello everyone. Today I'll be discussing one of the 5 applications of derivative that is given in the NCERT textbook. That's there in the exercise 6.1. That is rate of change of quantity. As the word says, rate of change. So we have change of one quantity, dependent quantity, with respect to the change in the independent quantity. The independent variable is x. So x changes to x plus del x. We find that there is a corresponding change in y. The change in x is del x. The change in y will be del y. This corresponding change in y that is the dependent variable with respect to the independent variable is known as the average rate of the change of y with respect to x. If we take up the change at the instance that del x is very small, that is limit del x tends to 0, that is at that instant, then this quantity limit del x tends to 0. Del y on del x is nothing but the instantaneous rate of change of y with respect to x, which is nothing but dy on dx. So what we have to see is which varying quantity varies with respect to its dependent variable. So this thing I'll be explaining through the questions of the NCERT textbook. To start with, I'll take up the first question of exercise 6.1. The question says, find the rate of change of the area of a circle with respect to its radius. So you need to find the change of area of a circle with respect to its radius. So the representation that we have is, you have to find dA on dr. At the instance when r is equal to 3 centimeters. That's at this instance you have to find the change of area. So how do we take up? In this, I have explained the solution through this format. That is, try to write down whatever is given, what is to be found, and then the expression that is required to find what is given relating the dependent and the independent variable. Like in this case, the area is changing with respect to radius for the circle. So the expression that we have is the area of a circle, which is A is equal to pi r square. So to find dA on dr, we need to differentiate A with respect to r. So we differentiate A with respect to r, we get dA on dr. So the derivative of pi r square is 2 pi r. Now what is given is at the instance r equal to 3 centimeter, which says that we have to find dA on dr at r is equal to 3. So put the value of r is equal to 3 in it. So that says it is 6 pi. So the area changes with respect to radius at the rate of 6 pi square centimeter per centimeter. Make sure you put a unit because this has a unit. It's a change of area with respect to radius. Now here one more thing I would like to say. The value of pi, if required, we'll use it as 22/7 or 3.14. But if not required, we can always keep it in this form. So we can have the answer in terms of pi. Until the question specifies that you have to use the value of pi as this, you don't need to change the value of pi. Keep the answer in terms of pi. The next question that I'll be dealing is the third question. The third question reads as the radius. Just note down whatever is given in the statement. The radius of a circle is increasing. That is, now the radius is changing. It's increasing uniformly at the rate of 3 centimeter per second. So this particular quantity represents change of radius with respect to time. So the representation that we have is dr on dt. Change of radius with respect to time is represented as dr on dt, which is 3 centimeter per second. Now, the next part of the question. Find the rate at which, again, the area of the circle is increasing when the radius is 10 centimeter. So there will be a change in the area. When the radius of the circle changes, there will be change in the area. The change in the radius is with respect to the time. So the area will also change with respect to the time. So you need to find the change of area with respect to time at the instance when the radius becomes 10 centimeter. So what you have to find, as I said, I'll be using a format. So what is given? Given, it is dr on dt. At the instance, r is equal to 10 centimeter. To find dA on dt. So again, you need a relation to connect A and R. The relation remains the same. It's a relation between area of a circle. It's a relation of area of a circle. That is, A is equal to pi r square. Now here, you have to find dA on dt, you will have to differentiate both sides with respect to t. So A's derivative with respect to t is dA on dt. Now pi is a constant, r square. R square is first differentiated with respect to r. So that gives us 2r. Then we need to differentiate r with respect to t. So we have dr on dt. Now use the value whatever is given to get dA on change of area with respect to time. And that is r is equal to 10. dr on dt is 3. So 10 multiplied by 2 multiplied by 3 makes it 60. Here also I have left the answer in terms of pi. So the answer is 60 pi square centimeter per second. The next question that I have is question number 4. Question number 4 says, an edge of a variable cube is increasing. Now here the object has changed. There it was plane. Here now it's an object. The edge of a variable cube is increasing at the rate of 3 centimeter per second. So this again specifies something. This is what is given then. Given is the edge, I am representing it as L. So it's dl on dt. It's 3 centimeter per second. Now what else is given? Or what you have to find? How fast is the volume of the cube increasing when the edge is 10 centimeter. So here again you'll find that the edge is changing at 3 centimeter per second, that is with respect to time. So you have to find the change in the volume of the cube with respect to time at the instance when edge is 10 centimeter. So the information that we have is dl on dt is 3 centimeter per second. L is 10 centimeter. And what we have to find is dv on dt. So we need to connect V and L. So the relation between V and L, that is known as expression, which is V is equal to L cube. So differentiate, for this also we'll have to differentiate both sides with respect to t. So the derivative of V with respect to t, dv on dt. Derivative of L cube, it's 3L square. Then you have dl on dt. Again, use the values. So what we have is L is 10. So you have this as 100 multiplied by dl on dt, that is 3. So together it is 900. So it's 900 is the change of volume with respect to the time. So the unit is cubic centimeter per second. The next question that I have taken is question number 7. Now in question number 7, what is the information that we have is the length x of a rectangle is decreasing. The change is specified. The change could always be increasing or decreasing. So here they have specified the change as decreasing at the rate of 5 centimeter per minute. And the width y is increasing at the rate of 4 centimeter per minute. There is a rectangle given which has length as x and y as its width. So the information that we have is the length is decreasing and width is increasing. So how is this represented? They are changing in both different directions. The change in different direction is represented with the help of a sign. So given is dx on dt. Since the word decreasing is there, I am associating negative sign with decreasing. And dy on dt is increasing, so obviously opposite of negative sign, it's positive. So we have it as plus 4 centimeter per minute. And the question says that we need to find when x is equal to 5 centimeter and y is equal to 6 centimeter, you have to find the change in perimeter, first part, and the change in area of the rectangle. Again with respect to time, so we need to connect xy through perimeter of the rectangle through x and y. So the relation that exists between p and xy is p is equal to 2 times x plus y. Now differentiate both sides with respect to t. We have dp on dt. Now that is giving us 2 times dx on dt plus 2 times dy on dt. Put the values. Dx on dt is minus 5. Dy on dt is plus 4. So the final result that we have after simplification of this is minus 2 centimeter. So we have already specified negative sign as decreasing quantity. So here also the perimeter comes out to be negative, which says that the perimeter decreases at the rate of 2 centimeter per minute. Now for the change in area, the relation that we have is A is equal to xy. Both sides differentiated with respect to t. We have dA on dt, that's equal to x times, we'll have the product rule here, y differentiated dy on dt, then x differentiated, we have dx on dt. The value of dA on dt with x as 8 and y as 6, as is given in the question, we have this value coming out to be plus 2 centimeter per second. This is plus 2. Plus 2 signified the positive sign, signified the increasing fact of the change. So here the area increases at the rate of 2 square centimeter per minute, because it's mentioned here it is in minutes. So this will also be in minutes. So this is how we need to take up the question of rate of change of quantities. So I have explained the questions. The next question that we have is question number 8. Question number 8 reads as: a balloon which always remains spherical on inflation is being inflated by pumping in of 900 cubic centimeter of gas per second. Find the rate at which the radius of this balloon increases. Inflated says again it's increasing, hence the radius needs to be increased. So that is the change that we have to find when the radius is 15 centimeter. So this information about 900 cubic centimeter per second is nothing but the volume change of that balloon which is a sphere. So we have it as dV on dt is 900 cubic centimeter per second. R is 15 centimeter. We have to find dr on dt. So the expression that connects V and R is V is equal to 4 upon 3 pi r cube. Differentiating this with respect to t, we get dV on dt is 4, this 3 r square, the 3 gets cancelled, it's 4 pi r square dr on dt. Now put the value dV on dt is 900. The 4 pi r square comes to the left hand side, 4 pi r square. This altogether is 1 upon pi. So 1 upon pi happens to be the change in y with respect to t, which is 1 upon pi centimeter per second. The next question is the 10th question. Here it says that, I'm not reading the textbook question, I'm just explaining it the question. It says that there is a ladder 5 meter long which is leaning against a wall. So I have used this Cartesian system to explain the leaning of the ladder. The hypotenuse of this represents the ladder. Now the question says that the ladder is being pulled away from the ground at some rate. The rate at which it has been pulled is mentioned as dx on dt is 2 centimeter per second. Now if you see that if this end is pulled away, obviously this end comes down. So you need to find the change of y coming down, that is towards the ground. For that we need to generate a relation between x and y. The relation that we have between x and y is, we can see that it forms a right angle triangle. So we can use this relation x square plus y square is equal to 5 square. Now change of x is with respect to time. So we have to differentiate both sides with respect to t. So on differentiating with respect to t, we get 2x dx on dt plus 2y dy on dt. Right side constant is equal to 0. So substitute the values. Now here one thing is that at the instance when x is equal to 4 meter is mentioned. So when x is equal to 4 meter, as we all know that it's a right angle triangle, if hypotenuse is 5 meter, x is 4 meter, then y is 3 meter, because 3, 4, 5 they form a Pythagorean triplet. One more thing you have to mention here, one I would like to mention is the unit that is there for change in length is given as centimeter per second. The length of the ladder is mentioned in terms of meter. So it will be convenient if we convert this length to unit to centimeter. So we have it as, so we need to convert we'll have to keep all the units same. For that purpose, I am converting meter to centimeter. So the length y will be now 300 centimeter. Substituting the value, we get that dy on dt comes out to be minus 8 on 3 centimeter per second. Now the significance of negative. What does this mean? As we have seen that dx on dt, we took it as positive, which explains that is moved. So the negative sign here signifies the opposite of what is happening here. Here pulling away is positive. So coming towards the ground will be negative. That's the significance of this. So that's what I have mentioned here. Pulled away from the wall, that is increase in the length of x, which is taken as positive. Therefore dy on dt negative says that y gets closer to the ground.